Hello good day viewers. In this tutorial we are going to apply L'Hopital's rule to evaluate these two limit problems. But before we start, I would like to remind you that you can only apply L'Hopital's rule if by direct substitution you realize an indeterminate form, right? That is 0 divided by 0 or infinity divided by infinity. Then you differentiate the top and the bottom separately before you substitute. All right, let's get started. The first one, we would like to evaluate the limit of the function x plus 2 divided by x squared plus 3x plus 2 as the value of x approaches negative 2. Before we apply L'Hopital's rule, I would like us to direct substitute to see the output. This will give us negative 2 plus 2 to the top. To the bottom, we have negative 2 all squared plus 3 multiplied by negative 2, then plus 2. To the top, we have negative 2 plus 2, which is equal to 0. To the bottom, you can see that this is going to give us 4, right? This is negative 6, and 4 minus 6 is negative 2, and negative 2 plus 2 is 0. So we have 0 divided by 0, which is what? Indeterminate. So therefore, we are going to differentiate the top and the bottom separately. So we say that this is the same thing as the limit of x approaches negative 2 of what? D over dx of x plus 2 divided by d over dx of what? X squared plus 3x plus 2. So we're going to differentiate the top and the bottom separately. If you differentiate the top, this is the same thing as the limit as x approaches negative 2. From the top, if you differentiate x, you have 1. You differentiate 2, you have 0. To the bottom, you differentiate x squared, you have 2x. Differentiate 3x, you have 3, right? Differentiate 2, you have 0. So from here, we can substitute x equal to negative 2 directly. This is the same thing as 1 divided by 2 multiplied by negative 2, then plus 3. This is the same thing as 1 divided by negative 4 plus 3. And finally, this is the same thing as negative 1 because negative 4 plus 3 is negative 1 and 1 divided by negative 1 is negative 1. This implies that after evaluating this limit, you're going to obtain negative 1. Let us go to the second problem. And here is our second problem. We would like to evaluate the limit of the function 2x squared minus 5x plus 1 divided by 3 plus x plus 6x squared as the value of x approaches infinity. You can clearly see that if you substitute infinity here, you're going to obtain infinity. Substitute infinity here, you have infinity. Infinity minus infinity plus 1 will still be what? Infinity. We divide it by, you do the same thing here. This will be infinity, this will be infinity. Plus 3 is still infinity. So we have infinity over infinity, which is what? Indeterminate form. So instead, we are going to differentiate the top and the bottom separately. So this is the same thing as the limit of x approaches infinity of what? D over dx of 2x squared minus 5x plus 1. We divided by d over dx of 3 plus x plus 6x squared. If you differentiate the top, this is the limit as x approaches infinity. To the top, we have 4x minus 5. To the bottom, this will give us 0. This will give us 1. So we have 1 plus. If you differentiate this, 2 will multiply 6. You have 12x. And next, we can divide the top and the bottom by x. So this is the same thing as the limit of x approaches infinity of 4x divided by x minus 5 divided by x. We do the same thing here. 1 divided by x plus 12 x divided by x. If you simplify this, you're going to have the limit as x approaches infinity of the top we have 4 minus 5 divided by x divided by 1 divided by x plus 12. You should observe that we have some fractions here. As you substitute x equal to infinity, the denominator will become so much bigger compared to the numerator. And remember, if you have a fraction, the more the denominator becomes bigger, the more the fraction tends to become smaller, approaching 0. So this will approach 0, likewise this one. So this is equal to 4 minus 0 divided by 0 plus what? 12. 4 minus 0 is equal to 4, and 0 plus 12 is 12. 4 can go into 12 3 times. Finally, this is equal to 1 divided by 3. This implies that as the limit of x approaches infinity in this function, it is going to tend to what? 1 divided by 3. As simple as that. So once you have an indeterminate form of the output, all you have to do is to differentiate the top and the bottom separately before you apply the limit. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.